Okay, so we're looking at Pearson Year 12 textbook, chapter 3.2, question 8. You've got a sign that's been strung by two different cables. The system's in equilibrium. So if we have a look at this diagram at the bottom, what you've got is a tensional force acting up and to the left, and we've got another tension force that's acting perfectly horizontal. And you have another tensional force, but that's due to the weight of the ball, or of this sign. So we can call that W for this particular case. So if I'm going to redraw this diagram as a free body diagram over here, what I'd end up with is a downward force, which will be weight, and then there's going to be another vector, which is going to be B, and over here we have A. And we also know, thanks to the diagram, that this angle here is about 60 degrees. So if I redraw this diagram as a vector diagram, knowing that it's in equilibrium, the weight force, all of the vectors should add up to 0. So I'm going to draw it in such a way that I finish where I started, and this here will be A. Now again, because we know that this angle here is 60, we know then this one here is 30 degrees, and from here we can essentially solve all of it. So W, the weight force, that's going to be equal to mg. So that's going to be equal to 100 times 9.8, which is 980. So let's start with finding out A. So the cosine of 30 is the adjacent over hypotenuse. So the adjacent in this case is W, and the hypotenuse is A. So if I want to find A, I rearrange, and I end up with W over cos 30, or 980 over cos 30, and you put that into your calculator, and you should end up with 1130 newtons. Moving on, if I now want to know B, that's I've got the opposite and I've got the adjacent, so I'm going to use tan 30, and tan 30 is going to be equal to the opposite, which is B, over the adjacent, which is W. So if I want to know B, that's going to be W tan 30, or 980 tan 30. And if you put that into your calculator, what you'll end up with is 566 newtons there. So there's other ways you can solve it. So if you look at A, you notice that A is the only thing providing a horizontal force to the left, so you can work out the components of A based on B, and then you can sub it in that way. But I would suggest that this way is probably the fastest, by drawing your force triangle. And there we go.